Welcome. Today we're going to be talking about section 8.7, special products and pattern factoring. So basically what we're going to be doing is we're going to be factoring like we did the day before, except for we're going to be looking at special patterns that help us factor more quickly. So the first thing we're going to talk about is difference of squares. So if we remember back to when we talked about multiplying polynomials and some had kind of special products that had shortcuts, one of those was with differences of squares. So if we have a polynomial set up like a plus b, that's one polynomial multiplied by a minus b, and this is just in general form, then let's see, if I just FOIL it out, so this would be the long way, but there's a shortcut to it. Do first a squared plus, let's see, negative ab plus ab minus b squared. Well, the minus ab plus ab cancel out. I'm left with a squared minus b squared. That's a difference of squares, right? A difference, subtraction of two squares, a squared and b squared. So basically, that was our shortcut from going from a plus b times a minus b. You didn't have to FOIL it out. You knew it was just the difference of the squares, so a squared minus b squared. Now we can use that shortcut for the reverse of it. If we see a polynomial that is a difference of two squares, so that would have to be a two-term polynomial that's subtraction sign in the middle, we have one square minus another square, then we can factor that into that a plus b times a minus b form. So let's see some examples of this. So let's see. Our first one right here, let's see. How we know we can use that difference of squares shortcut is we have to check three things. First of all, is it actually a difference? Is this subtraction? Yes. Then we have to check both of our terms. Are they both squares? Let's see, well, y squared, yep, that's just y squared. 4, that is a square, that's 2 squared. Now if we remember, a squared minus b squared can be factored as a plus b, a minus b. Well, in this case, a is y, b is 2. So when I factor that, this is going to be y plus 2, y minus 2. Okay, let's try another example. Let's see, first of all, let's check if it's a difference. Yep, it's two terms, it's a difference. Let's check if they're both squares. Well, 121, that's the same as 11 squared. 4b squared, well, that's the same as 2b quantity squared. Remember the constant out front, what we're multiplying by, also needs to be a square in order for this to work. Well, that 11 is going to be our a. 2b is going to be our b. So my final answer in factored form is going to be 11 plus 2b times 11 minus 2b. Let's see, I want you to try this one on your own. You could pause the video to give you some more time to work on it. I'm going to just write up here, write what we just talked about. A squared minus b squared, same as a plus b, a minus b. Okay, let's go over this one. So first of all, it is a difference problem. It's a difference of two squares. Well, let's see, 64g squared. A square, well, 64 is a square, that's 8. G squared is a square, that would just be 8g squared, 8g quantity squared would be 64g squared. And let's see, h squared, that's definitely a square. That's just h squared. Well, let's see. 8g is my a, h is my b. My final answer in factored form is going to be 8g plus h times hg minus h. Okay, let's go through our factoring steps. So what we're going to do is we're going to combine everything we learned yesterday with this new shortcut of difference of squares. and we're just going to practice factoring a bunch of polynomials. So first step, well, first of all, you want to make sure it's in standard form before you begin. Then you're going to take out the greatest common factor. Remember that greatest common factor needs to be part of every single term. We're going to take that out as our first step if there is one. And we still want to write it. That's part of our final answer. And then you have to check, is it is there 4 terms? And if there is, that's when we have to group it. And we do factor by grouping. If there is 3 terms, that's a trinomial, and we use our trinomial group in method. And lastly, is it a special product? So is it just 2 terms? Can it be a difference of squares? Can we use that pattern? If so, use that. So if it's 4 terms, factor by grouping. If it's a trinomial, you're going to use your trinomial method. And if it's a 2-term special product, difference by squares, then you can use that method. Okay, step 1 for this problem is we want to check to see if there's a greatest common factor. Well, I'm noticing that I have a 5 right here in our first term, and 80 is divisible by 5. So if I factor out a 5, now we make sure to write that 5 up front, that's going to be 5x squared minus 16. And that's 16 because 80 divided by 5 is 16. Now, let's see, I'm noticing that I'm left with a 2-term polynomial. So my next step is I want to see if this is a difference of squares. So it definitely is a difference. Let's see, are there 2 squares? Well, x squared is definitely a square. 16 is also a square, that's 4 squared. So that means our x is our a value, 4 is our b value, and remember, a squared minus b squared is equal to a plus b times a minus b. So I'm going to rewrite this as 5, remember we're going to drop that 5 down, x minus 4, or x plus 4, x minus 4. If you switch these two, the order of these two, you would still have the exact same answer. So 5 times x plus 4 times x minus 4. Okay, we're going to work on another polynomial right now. Let's see, the first thing I'm going to do is I'm going to check to see if I can find a greatest common factor. Well, 12, 5, and 25 do not have a greatest common factor. They don't have any common factors at all. So the next thing I'm going to do is I'm going to recognize that this is a trinomial. So I need to use my trinomial method. So let's see. My factors of and what I want to add up to be. I'm going to make that little table, and now let's see, and we have to recognize that we have a constant. This is of the form ax squared plus bx plus c, not just x squared plus bx plus c. So I'm not going to put a negative 25, find the factors of 25. I'm going to find the factors of 12 times 25, which is 300. And now I'm not actually doing 12 times 25, I'm doing 12 times negative 25. So I actually want to find the factors of negative 300. Well, there's many factors of negative 300, so I'm going to save us a couple steps, and I'm going to remind us that we're looking to add to 5. So I'm looking for 2 factors that are only 5 apart. And I'm going to tell you our 2 factors are going to be 15 and 20. Now we need to remember that 15 times 20 is 300, but I really want negative 300, so I need to test this both ways. Negative 15 and a positive 20, because that would get us to negative 300, or 15, positive 15, and a negative 20. That would also get us 300. Well, negative 15 plus 20 is 5. 15 minus 20 is negative 5. Well, I really want to add up to a positive 5, so these are the set of factors that I'm going to use. My next step is I'm going to rewrite my equation, or my polynomial, with those factors. So I'm going to rewrite it as 12x squared minus 15x plus 20x minus 25. And that comes from, let's see, this plus 5x here, I'm just rewriting it as negative 15x plus 20x, because that's the same as 5x. Our new equation, our new polynomial is just our original one, not in simplest terms, before we combine like terms. Now let's see. We're going to recognize that now we have a 4-term polynomial, so we are going to factor by grouping. So right here is going to be my first group, and right here is my second group. Let's see, I realize I forgot an x right here. There we go. Now I'm going to take a look at my first group, and let's see, what is my greatest common factor? What can I factor out? Well, they both have an x, I can factor an x. 12 and 15, let's see, the greatest common factor is both 3. So 3x is my greatest common factor of both terms. I'm going to factor that out, and I am going to get a 3x times 4x minus 5. Let's see, now if we take a look at our second polynomial, 20x and minus 25, I can factor 5 out of both of them. 5 is my greatest common factor. So that would be 5 times, let's see. If I factor 5 out of 20x, I'm left with 4x. If I factor a 5 out of negative 25, I'm left with 5. Now let's take a look at the whole entire polynomial right now. They both have a 4x minus 5. So I'm going to take both of them, and I'm going to factor them to the outside. And I'm left with that 3x plus 5 from right here, 3x plus 5, times 4x minus 5. Remember, we could factor in such a way because they were both multiplied by 4x minus 5. This right here is my final answer. Okay, let's see, let's try another one. So 5x to the 5th minus 45x. So first thing we're going to do, step 1, we're going to find the greatest common factor. So let's see, 5 and 45 are both divisible by 5. That's our greatest common factor. X to the 5th and x are both divisible by x. So my greatest common factor for both terms is going to be 5x. So I'm going to start by factoring it out. Remember, I need to write that right here. So 5x times, let's see, what's left is when I factor 5x out of 5x to the 5th, I'm left with x to the 4th. Let's see, and then minus when I factor 5x out of 45x, I'm left with just 9. The next thing I'm going to notice is that I have 2 terms. I notice that it's a difference. And let's see, are they both squareds? Well, x to the 4th, that's the same as x squared. Squared, thinking back to our exponent rules. X to the 4th is x squared. Squared, and 9 is going to be 3 squared. So it is a difference of squares, where let's see, a is equal to that x squared, b is going to be equal to that 3. So remember, a squared minus b squared is a times b in parentheses, or a plus b in parentheses times a minus b in parentheses. So our final answer is going to be, we're going to drop down that 5x times x squared plus 3, that's from our a plus b, times a minus b, which is x squared minus 3. And right here is our final answer. Okay, 6x to the 4th minus 96. I want you to try this one on your own, pause the video and work it out. Okay, let's go over this one. So 6x to the 4th times, or minus 96. First thing we're going to do is we're going to check if there's a greatest common factor. Well, 96 is divisible by 6, so 6 is our greatest common factor. We're going to factor it out. Still going to rate it, so I'm left with x to the 4th minus 16. That 16 comes from 96 divided by 6. Now let's see, I'm noticing that there are 2 terms right here, and it is a difference. Well, let's see, are they both squared? Well, just like in that previous problem, x to the 4th is the same as x squared squared, and 16, that's a square, that's 4 squared. So this problem becomes 6, remember we always got to drop that 6 down, x squared plus 4, x squared minus 4. Now the great thing about all these factoring problems, if you're ever unsure that you factored something incorrectly, you can always just multiply it out. and check. These problems are super easy to check. Okay, 2m cubed. Okay, let's try this problem. Step 1, we are going to look for greatest common factor. Well, I have coefficients of 2. Let's see, there's no coefficient on the m squared, but we remember when there's no coefficient, that's the same as it being a 1, a negative 50, and a negative 25. So when we do this problem, we can notice that none of these coefficients have any common factor. So there's no greatest common factor that we can take out. The next thing we need to recognize is that this is a 4-term polynomial, meaning that we need to factor by grouping. So I'm going to divide it up into 2-term groups, and as I divide it up, we need to remember one quick thing, is this minus sign is really a minus 50m. So the minus sign can't be outside of the parentheses. Instead, I need to change this to a plus sign and change this to a negative 50, right? Plus negative 50m minus 25 when I factor by grouping. Now I'm going to take a look at my first polynomial, 2m squared or 2m cubed plus m squared. Well, I'm going to factor out. Let's see, what can I factor out of both of these? What's the greatest common factor? Well, I noticed that they both have an m squared in them. I can factor out an m squared. So then I'm left with m squared times, well, if I factor out an m squared from 2m cubed, I'm left with just a 2m. And I can check that by just distributing that m squared back in, and I notice that m squared times 2m is in fact 2m cubed. Plus, well, what happens when I take out m squared from m squared? It's not just nothing. This is where we need to remember that, well, when we distribute in, that's the same as multiplying. When we factor out, we divide. So that would be m squared divided by m squared, which is 1. So right here, that's just a 1. And if you go back and if you check it, and you distribute that m squared to that 1, oh, that would be m squared. That would be what we originally had. So we're good. We're going to do plus, well, let's see. What is the greatest common factor of negative 50m and negative 25? Well, that's going to be negative 25. I'm going to take out a negative 25. And then when I take out negative 25, I'm left with an m and a positive 1. And again, that's because I'm dividing each term. I'm dividing negative 50m by negative 25, which gives me, whoops, sorry, that was supposed to be a 2m. There we go. And negative 25 divided by negative 25, that's just 1. Now I can recognize that, hey, both my terms, both this m squared and this negative 25, are being multiplied by 2m plus 1 and 2m plus 1. So I'm actually going to take that 2m plus 1. I'm going to divide both of those terms by 2m plus 1 and factor that out. So then I'm left with that m squared minus 25, or you could say plus negative 25, times that 2m plus 1. And that right there is your final answer. Okay, I have one more problem for you all. 2x to the 4th plus 2x cubed minus 12x squared. The first thing, we're going to look for a greatest common factor. So first of all, if we just start with our coefficients, 2, 2, and 12, our greatest common factor, those coefficients, is 2. But also we can notice that each of these terms have x's in them. X to the 4th, x cubed, x squared. Our greatest common factor of those is x squared. So actually our total greatest common factor for each term is 2x squared. So let's factor that out. So when I factor out a 2x squared from each term, well, I'm left with just an x squared for my first term, because remember 2x to the 4th divided by 2x squared, that's just x squared. When I divide 2x cubed by 2x squared, I'm just left with an x. And when I do negative 12x squared divided by 2x squared, I'm just left with a minus 6. Now, within my polynomial, within my parentheses, I have this 3-term polynomial. So I'm going to use one of my trinomial methods. I notice that this is just an x squared plus ax plus b trinomial, not an ax squared plus x plus b. So I'm going to make my little chart over here of my factors of 6 right here, aiming to get to a negative 6. And we want to see what they add up to. So let's see. What are some of my factors of negative 6? That would be, let's see, 1 and 6. And remember, I'm looking for a negative 6. So that means I need to have a positive multiplied by a negative. So I could have negative 1, or positive 1 and negative 6. I could have negative 1 and positive 6. I could also have 2 and 3 are also both factors of 6. But remember, one needs to be positive and one needs to be negative in order to get negative 6. So I could have negative 2, positive 3. I could have negative 3, positive 2. Sorry, yep, I did write that right. Okay, let's see what they add up to. Remember, what we want to add up to right here is we want this coefficient right here, which is a 1. So our really aim is finding whatever one adds up to 1. Because remember right here, an x is the same as just a 1x. So 1 plus negative 6, well that's negative 5. Negative 1 plus 6 is 5. Negative 2 plus 3 is 1. And negative 3 plus 2, that is just negative 1. So finally, to end, right here are the factors we are looking for. Now I can rewrite this. Those are my factors, so I can rewrite this as just x minus 2 times x plus 3. Now, we're forgetting one thing before we end. We factored out this 2x squared, so I also need to write that down, 2x squared. So my final answer is 2x squared times x minus 2 times x plus 3, and that is my final answer. Thank you for watching today's video.